Okay, let's go over a combined gas law problem. Now, I want to specifically talk about this problem because I think it's a good example as to why it's really important to keep track of all of your variables. The combined gas law oftentimes uses a whole bunch of different variables, and it can be kind of hard to keep track of them if you're not physically writing them down. Um, what in any gas law problem, whether it's combined gas law, whether it's Boyle's gas law, or even if I'm doing a gas stoichiometry problem, uh, I always want to keep track of my variables. It's very easy to misassign a variable. I think it's also very easy to maybe forget to convert a variable. Um, there's just a lot to keep track of in the gas law unit. All right. So let's look at this problem. If a sample of gas occupies a volume of 3.5 liters 57, at 57 degrees Celsius and 0.45 atmospheres, what temperature in degrees Celsius would the gas occupy at STP? Okay, so right off the bat, whenever you read a gas law problem, I would immediately assign the numbers given to you in the problem. They're likely important, and you're probably going to end up having to use them. What do these numbers really represent? These are the initial conditions of our gas, right? So I would literally make a grocery list right on the side. Our initial volume, which I'll just call V1, is 3.50 liters. Our initial temperature is 57 degrees Celsius. Our initial pressure is 0.45 atmospheres. Do we know, are we given any indication about how many moles we may have here? No, right? I don't see. I actually don't even know why I made this blue. It should have been green. But what I want to show you all here is that if there's no mention of a variable, then it probably is being held constant, or it's unimportant to our problem here. So I'm actually not even going to worry about moles at all. Okay? Do we know R? Yeah, R is just a constant too. Arguably, maybe I could even add it over here that R is equal to 0.08206. And you can even include the units. Mole over K. Yeah. Okay. Well, let's continue with our grocery list because we were given some other information. We were asked what temperature would the gas occupy at STP? And this is a very loaded 3 letters, all right? Before we even deal with STP, let's think about what the question's asking. They want us to determine what the new temperature is going to be. So T2, I'm going to say, I have no idea. I don't know what temperature 2 is, but that's our goal, right? That's what we're trying to figure out. What about volume, right? What about the new volume? Well, it's at STP. So the new volume here is just going to be STP volume, which is 22.4 liters, right? It's just a condition. It's just a condition. You can think of it almost like a season. Summer is a warm condition of the year, right? Whereas winter would be a cold condition. How do conditions change? Well, as the seasons change, you change how many layers of clothes you wear. Maybe your mood changes. Well, for gases, one season, I guess you could call it, is STP, standard temperature and pressure. So what about pressure? Well, at STP, the pressure actually, I forgot to include here, is just 1, right? It's 1 atmosphere. So we do have a P2. I'll just say 1.00 for sig fig's sake. All right, and we got our grocery list. if you really wanted to include moles here, I mean, I guess you could, but we're dealing with 1 mole of gas, right? So we have V1, T1, P1, and V2, P2, where we don't know T2. The reason why this is the combined gas law is because we're actually going to be using multiple gas laws to figure this out. I can see Boyle's gas law right over there, right? I can also see Charles's. So we're using actually 2 gas laws here at the same exact time. They all are still coming from PV equals nRT. And if it helps, even just to underline, right? We know our P. We are trying to figure out T, but we are given 1 T. And we also have volume. N and R are irrelevant to this problem. So now we can set this up, right? I know that if I were to set PV equal to T and I wanted to get T over to the left side, you would have P1 times V1 divided by T1 equals P2 times V2 divided by T2. And I really don't think that you need to spend your time memorizing even the combined gas law or Charles's law or Boyle's law. You should understand what those laws represent, but all of this I don't think needs any memorizing because you just need to recognize that our gas is changing, the conditions are changing, and that the only variables that are changing here are pressure, volume, and temperature. So I want to get all the variables onto the same side so that they still have that relationship to R, okay? At this point, this has now become just plug and chug, right? Our P1 is 0.45 atmospheres. Our V1 is 3.50 liters. Our T1 is 57 degrees Celsius, which we actually have to convert. We have to convert that to Kelvin, so I'm going to add 273 here. All right? Adding 273 is how we convert from degrees Celsius to Kelvin. Okay? And we're going to set that equal to the other side of the equation, which is our P2. This is all just STP, right? 1 ATM times V2, which is 22.4 liters, all over T2. And I don't know what T2 is. Our goal is that we are going to try and figure out what T2 is, all right? So with a little bit of algebra, you should be able to figure out T2 here, okay? Watch out. This question does say that you want to convert it back into Celsius at the end, all right? Pay attention to units. I strongly always recommend writing them down so you don't get lost in your work. But in general, I think this is how you should approach not just the combined gas law problem, but any type of gas problem. I think gas stoichiometry is typically more difficult than this. But that being said, I think keeping a grocery list, keeping a list of your variables and identifying what they are can help you get to the type of math you need to solve. Because maybe you just read this problem and you're like, okay, I see some numbers that look important, but I'm not sure how to actually do the math itself. Or maybe you do feel confident with gas law math, but you don't know where to begin. Maybe you don't know how to set up the problem. And to that I say, you don't always need to know how to set up the problem. What I think is if you make the list of your variables, it makes it much more clear where you need to go, right? Like, we knew based off looking here that we had all these variables except for T2, right? I hope that was helpful.